Every serious measurement in the modern world runs on 10. 10 millimeters to a centimeter, 1,000 grams to a kilogram, 100 cents to the dollar. Then there is the clock on the wall. 60 seconds to a minute, 60 minutes to an hour, a way of counting inherited from scribes who pressed wedges into wet clay in southern Iraq around 4,000 years ago. France fixed that once. In 1793, the Republic decimalized the day itself. 10 hours in a day, 100 minutes in each hour, 100 seconds in each minute. Clockmakers built the movements. A few of those clocks survive in French collections, and some of them carry 2 rings on the same dial, decimal time on the inner one and the old hours on the outer, because nobody could yet be sure which set of numbers a customer would actually use. Official decimal time lasted about 17 months. The rest of that project went on to conquer the planet. The meter, the liter, the kilogram, the whole system of moving a decimal point instead of doing long division, adopted by almost every country on Earth. The one piece of it that touched the clock died before it was 2 years old, and no government anywhere has seriously tried again since. 2 things have to be conceded before any of this gets interesting. The first is that the clock is not really base 60. The day has 24 hours, not 60. The week has 7 days. The months are a mess, and the year refuses to divide by anything cleanly. Only the 2 subdivisions under the hour are 60ths, and they came from a different place than the 24 did. This is a patchwork, assembled by different people for different reasons over about 3,000 years. And anyone who tells you the world runs on Babylonian time is compressing a much stranger story. The second concession matters more. Decimal time really is better on one axis, and it is the axis that made the metric system unstoppable everywhere else. With decimals, converting units means shifting a decimal point. No remainders. No mental arithmetic. Under a decimal clock, a quarter of a day is exactly 2.5 hours, and a fifth of an hour is exactly 20 minutes, and every duration in a ledger can be added the same way money is added. So the question is not whether 60 is elegant. It is not. The question is which axis actually decided the fight, because it clearly was not that one. 2 axes did the deciding. The first is divisibility. 60 splits evenly into halves, thirds, quarters, fifths, sixths, tenths, twelfths, 15ths, 20ths, and 30ths. 100 does not split into thirds at all. Every calculation used to happen in a scribe's head or on a counting board. And under those conditions, the difference was not aesthetic. It was the difference between a clean answer and an endless one. A third of an hour is 20 minutes. A third of a decimal hour is 33 and a third minutes. And then somebody has to decide what to do with the fraction every single time, forever. The second axis is the one that killed the French experiment, and it is the axis this whole story turns on. Time is a coordination standard. A merchant can buy a meter stick on his own and start using it that afternoon. A clock is worthless unless the other clocks agree with it. Start where the 60s come from, because it is not where most people assume. The scribes of Mesopotamia, the Sumerians first and then the Babylonians after them, wrote numbers in a place value system with 60 as the base, 60 units, then a new column. It is the same idea as our columns of tens, and it was in place well over 1,000 years before anyone in Greece did serious astronomy. The Babylonian astronomers who used it left thousands of tablets of positions, predictions, and tables, and it was Otto Neugebauer, working through them in the middle of the 20th century, who established just how sophisticated that mathematics really was. There is a tablet in the collection at Columbia University, cataloged as Plimpton 322, that has become the poster child for this. It is a table of numbers in sexagesimal columns, and it is genuinely remarkable. It is also a magnet for overreach. Eleanor Robson has argued at length that reading it as an ancient trigonometry table says more about modern mathematicians than about Babylonian scribes, and that the likelier context is a teacher's problem list. That argument has not been settled, And why 60? Here I have to be honest about the limits of the evidence, because there is no surviving ancient text in which anyone explains the choice. None. Theon of Alexandria, writing in the 4th century AD, more than 2,000 years after the system was already running, said 60 was chosen because it divides so conveniently. That is a late guess by a working astronomer who found it useful, not a record of the decision. Neugebauer argued instead that the base grew out of older systems of weights and measures colliding, 60 emerging as the number that reconciled units that were already in use. There is also a popular story about counting the 12 finger joints on one hand and the 5 fingers of the other, and it is repeated constantly, and it rests on almost nothing. 12 times 5. Very tidy. No Babylonian ever wrote it down. The reading I find most convincing is the metrological one, because it does not require anyone to have been clever on purpose. Systems like this usually accumulate. Somebody's grain measure and somebody else's weight standard have to be reconciled. The number that reconciles them becomes the number everyone writes in, and 1,000 years later, it looks like a design. The 24 came from somewhere else entirely. Egyptian priests divided the night by watching stars. Particular star groups, called deacons, rose at intervals through the darkness, and the sequence of their risings marked off the passing of the night in 12 parts. Sarah Simons is among the specialists who have worked through the star tables painted inside Middle Kingdom coffin lids, which are essentially instruments for doing this. Daylight got 12 parts to match, and there is your 24. But those hours were not equal, and this is the detail that most people miss. A daytime hour was 1/12 of however much daylight there happened to be. In summer, it stretched. In winter, it shrank. For most of human history, an hour was not a fixed quantity at all, which meant that a minute, a 60th of a thing that changed length with the season, was not a quantity anyone could actually use. Think about what that meant for an ordinary working life. A field hand in a Roman province or a medieval village did not check a number. He worked between bells, or between the moment the sun cleared a particular ridge and the moment it dropped behind the tree line, and if the working day in July was half again as long as the working day in January, that was simply what a day was. Appointments were made by event, not by clock. Meet after the market opens. Come when the bell rings for the second office. Nothing in that life had any use whatsoever for a 60th of anything. So the 60s sat in the hands of astronomers for a very long time, doing a completely different job. Greek astronomers took the Babylonian sexagesimal fractions because they needed precision in dividing circles and tracking positions, and a circle of 360 parts, each divisible into 60ths, was an extremely comfortable thing to compute with. Ptolemy's Almagest, compiled in Alexandria in the 2nd century AD, is written in those fractions throughout. When that tradition passed into medieval Latin, the first small division of a degree was called the first minute part, and the next division down the second minute part. Those two clumsy Latin phrases are where the English words minute and second come from, not from clocks, from the fractions on an astronomer's page, which produces one of the strangest facts in this whole story. The second was named, defined, and used in calculation for something like 1,400 years before any machine on Earth could keep one. Mechanical clocks changed that slowly. When weight-driven clocks spread through European towns in the 14th century, they had no way of speeding up in summer and slowing down in winter. So the hours they struck were equal by force of engineering. That was the real break. The hour became a fixed quantity because a machine could only produce fixed quantities. Minute hands came later and were rare for another 2 centuries. Jos Berge, working in the 1580s, is generally credited with clocks that could indicate seconds for astronomical observation, though the details of the attribution are argued over. The change that mattered arrived in 1656, when Christian Huygens applied the pendulum to a clock movement and cut timekeeping error by orders of magnitude at a stroke. Now notice the sequence, because it is the mechanism of the whole video. By the time anybody could physically measure a second, every table, every star catalog, every navigational almanac, every trained calculator, and every clock face in Europe was already sexagesimal. The 60s had a 1400-year head start on the machinery. That is the installed base. Charts, tables, trained hands. Rewriting the 60s would have meant recomputing centuries of astronomical work that people's lives at sea depended on, and doing it with no calculating machinery for a gain measured in convenience. And two governments have tried to overturn it, one in Europe and one in East Asia that had a 2,000-year head start on the idea. Paris, the winter of year 2, which the rest of Europe was still calling 1793. The Republic has already remade weights, measures, and the calendar, and on the 5th of October, it decrees a new day, 10 hours, each of 100 minutes, each of 100 seconds. Every public clock is supposed to change. Clockmakers, who have spent the year taking royal emblems off dials, now get orders for movements that nobody has ever built before. The first time I saw one of those decimal dials in a museum case, I assumed somebody had made it as a novelty, a joke object for a collector. It was a government instrument built to a legal standard by a shop that expected the order to be the first of thousands. Picture the shop. A workman is filing a new dial with 10 large numerals where 12 used to be, and behind him on the bench sits a finished piece with both scales engraved on it. Decimal inside, traditional outside, because his customers have not agreed to anything yet. He is being paid to make a hedge. The clocks that survive with that double dial are, in a sense, a record of the exact moment the reform started losing. Because a clock is not a meter stick. If a draper decides to sell cloth by the meter, he needs one ruler and his own willingness. If a citizen decides to keep decimal time, he needs the coach service, the market, the church, his employer, the courts, and his neighbors to have decided the same thing on the same morning. Every clock in France was an object with a price, and there were an enormous number of them, and each one that stayed on 12 hours was a small vote against the reform that cost its owner nothing. The state suspended mandatory decimal time on the 7th of April, 1795, roughly 17 months after it began. The decimal calendar hung on longer, with its 10-day weeks that gave workers one rest day in 10 instead of 1 in 7, which was about as popular as it sounds, and it was abolished at the start of 1806. The meter and the kilograms sailed on and are still here. There is a second casualty of that project that almost nobody notices, and it is hiding on an object most people have owned. The same reformers decimalized the circle. Instead of 360 degrees, the new unit cut the right angle into 100 parts, 400 to a full turn, and it was given the name grade, later gradian or gone. It is a perfectly sensible unit. It survives in a few European surveying traditions and almost nowhere else. And the reason most people have met it at all is that scientific calculators still carry a third setting next to degrees and radians. The grad key. That key is a fossil of the same failed reform, sitting unpressed on millions of desks because every chart, every sextant, every table of star positions, and eventually every satellite navigation system was already written in degrees, minutes, and seconds. Now, the second attempt, and it ran the other way. China had been dividing the day into 100 parts for a very long time. The unit is the K, and 100 KE to a day is attested from the Han period onward, measured off on the float of a water clock. That is a decimal division of the day in daily official use, roughly 2,000 years before the French Republic thought of it. Each key is a little over 14 modern minutes, but it ran alongside a second system, the 12 double hours that name the day for everyone else, and 100 does not divide by 12, 8 and a third key to a double hour. Every conversion in an astronomical bureau carried that fraction around like a stone in a shoe. Several dynasties tried to fix it by changing the number to 120, to 96, to 108, and each time the change was reversed and the 100 came back. The fix that finally stuck came with the great calendar reform of the 17th century, the one carried out by Chinese court astronomers working alongside Jesuit missionaries when the day was set at 96K. Historians differ over whether to date the change to the late Ming reform itself or to its full adoption under the Qing. And I am not going to pretend the sources speak with one voice on that. 96 is what stuck. 96 divides by 12 exactly 8 key to a double hour. No remainder, no fraction to carry. Read that carefully. China had a decimal time unit, kept it for 20 centuries, and then deliberately abandoned it in favor of a number that divided cleanly against the system already in place. Two civilizations, opposite ends of Eurasia, no contact between the two decisions, and both landed on the same answer: divisibility and existing practice beat arithmetic elegance. So here's the twist, and it is not that 60 is secretly superior. Look at where the base did change. Under the second, everything is decimal. Tenths, hundredths, milliseconds, microseconds, nanoseconds. No commission was convened. No law was passed. No country resisted. No clockmaker hedged his dial. Decimal simply walked in and took the whole territory because nobody was already there. Before the 20th century, no instrument on Earth could resolve a tenth of a second, so there were no tables to rewrite, no habits to break, no contracts written in 60ths of a second, no installed base at all. Above the second, the world was full of clocks. Below it, the world was empty. Empty ground, decimal wins. Decimal never lost this fight on merit. It won every single part of the field that was unoccupied, and it lost every part that was already furnished. The line where those two territories meet is 1 second long, and it is sitting on the stopwatch in your pocket. The modern definition makes the joke complete. Since 1967, the second has been defined by the cesium atom as a fixed number of oscillations, 9,192,631,770 of them. A precise decimal count used to define a unit whose name comes from a Latin translation of a Greek astronomer copying Babylonian fractions. The 60s are not confined to clocks either, which is easy to forget. Every coordinate on Earth is still quoted in degrees, minutes, and seconds of latitude and longitude, the same units Ptolemy's fractions produced, carried forward through 15 centuries of sea charts into satellites that calculate in binary and then convert the answer back into Babylonian 60ths so a human can read it. A phone doing that conversion is performing a small act of archaeology several times a second. The same fight is still running, and it has moved into software. In 2022, the international body responsible for these decisions resolved to stop inserting leap seconds by 2035, the little corrections that keep atomic time lined up with the turning Earth. The argument for stopping them is not astronomical. It is that leap seconds break computer systems that were never written to expect a minute with 61 seconds in it. The installed base has changed material from brass to code, and it is winning again. There was one more attempt, and hardly anybody remembers it. In 1998, a Swiss watch company launched a decimal internet time, 1,000 beats to a day, no time zones, one number for the whole planet. It was in watches, on a website, in a few video games. No installed base to fight and no installed base to inherit either, which turned out to be the same problem in reverse. A standard that nobody has to use is a standard that nobody uses. It is gone. Completely. Not even a fossil key on a calculator. Tomorrow, open the stopwatch on your phone and start it running. Watch the digits on the right spinning through hundredths in clean tens, and the field to their left climbing to 59 and rolling over. Both of those are on the same screen, half a centimeter apart. The seam between the metric system and a Babylonian counting method is right there, and you can put your thumb over it.